As we look today at the property of logarithms, we're going to be moving away from graphing and more into the algebraic manipulation of logarithms and see that they have a number of rules that relate to exponentials and just kind of the inverse of each of those rules. So our three rules that we're going to be focused on today are the product, the quotient, and the power property. And the product property says that you can take a logarithm that has multiplication inside the logarithm and turn that into two logarithms that are added together. And by breaking that up, notice the base does stay the same. Then, secondly, you can take division inside a logarithm and turn that into two logarithms that are subtracted together. So division becomes subtraction, multiplication becomes addition. And then third and finally, you can take a exponent here. We have log base m of m raised to the x, and that exponent comes out front as a multiplying coefficient. And so that is what we call our power property, and it becomes the product in the front of that. So what we're going to do is we're going to do three different types of examples in overview. First, we're going to take multiple logarithms and combine them into one. Second, we're going to take a single logarithm and spread it out and expand it. And then thirdly, we're going to use those properties to take multiple logarithms, combine them into one, and then evaluate it using our logarithm ideas that we learned at the beginning of the chapter. So let's start here. In order to combine logarithms, you must have the same base. So as we analyze this first one, we see we do have the same base. Both have base 2. This is a plus. And so what we're going to be doing here is a plus outside logarithms becomes multiplication inside logarithms. And so we have log base 2 of 6 times 4, which is 24. And so our single logarithm will be log base 2 of 24. Pretty straightforward. Multiplication on the inside of a logarithm becomes addition on the outside. Our second one, log 16 minus log of 2, both base 3. Well, subtraction outside a logarithm becomes division inside a logarithm, still with base 3. And so that leads us to log base 3 of 8. So hopefully you're seeing these are very straightforward as we're just learning a couple new rules of manipulation of logarithms. Our third one, we have a number out front. Perhaps you remember what that is. That means that is an exponent on the inside. So that's going to become the log base 5 of 3 squared plus the log base 5 of 2. And maybe you could think about doing this in one step. You might be able to do that in one step, but either way, this is the log base 5 of 9 times 2, which is the log base 5 of 18. Now, some of you very well may be able to do that in one step, but I'm just showing you the multiple step process to make it straightforward for you. Okay, our last one, we've got the 4 outside, so that's going to become log of x to the 4th minus log of y plus log of y squared. So what does this become? Well, let's take a look. We have the log of x to the 4th minus the log of y. So the log, and notice there's no base, so that base is 10. The x to the 4th is in the numerator. The y is in the denominator. And the y squared will also be in the numerator. So just a little bit of a unique problem. The y squared and the y cancel. That's going to leave us with log of x to the 4th y. And there is an invisible, I hope you do remember there is an invisible base here. That invisible base is 10. We do not need to write that invisible base, but just remember that that base is always there. That is called the common log. So just an example how you might take a look at taking multiple logarithms and writing them as one logarithm. Now let's go the opposite direction. Let's take these next 4 and let's expand these logarithms. So multiplication inside becomes addition outside, and the exponent is going to become multiplying in the front of that logarithm of y. So we have the log base 7 of 4 plus the log base 7 of x plus the log base 7 of y cubed. I'm just doing 2 steps here. Final answer, log base 7 of 4 plus log base 7 of x plus 3 log base 7 of y. You might be able to do that in 1 step, but just trying to show you can just break it up and take it nice and slow. Our next one, division becomes subtraction, so this is going to become minus a y, and the 15 and the x will be pluses connecting. So we're going to have 3 logarithms of our final product. So here we go. Log base 8 of 15 plus log base 8 of x minus log base 8 of y. Hopefully that's pretty straightforward. Here we have next one. We have log of 6, the square root of 3x. Please remember that is an exponent of 1/2, and so I'm just going to rewrite this maybe to start us off. Log of base 6 plus the log of 3x to the 1/2. Now, that 3x to the 1/2, that's going to distribute to both the 3 and the x, and so that's going to give us log base 6, log of 6 plus log of 3 to the 1/2 plus log of x to the 1/2. Just showing there's a lot of ways to go about this. Our final answer, log of 6 plus 1/2 log of 3 plus 1/2 log of x. So just a number of different possibilities here. We're not showing you all the scenarios, just trying to show you a variety of different possibilities. This 4, we can distribute it to both the 3 and the x. So if you want to think of it that way, that's log of 3 to the 4th, x to the 4th, if that helps you. That's going to lead us to breaking it up with addition, log base 2 of 3 to the 4th plus log base 2 of x to the 4th, which is going to bring that 4 in front of log base 2 of 3 plus 4 log base 2 of x. So once again, I'm not trying to show you all the different possibilities, but just a couple different scenarios here. In each one of these, we've kind of isolated and expanded slowly to get our final answers. Some people like to do it a little bit faster, but there's really multiple ways you can approach this. Okay, now let's take what we remembered from our last first couple sections of the chapter and combine it with our new rules and try to evaluate each expression for a number at our final product. So we have an addition problem here. So as you know, that's going to be the log base 4 of 8 times 2, which is 16. And now we're going to think about this as we transform this. Log of base 4 of 16. Well, that means we could think of this as say, hey, 4 to the what equals 16. And hopefully you'd see 4 to the 2 equals 16. And so 4 to the 2 equals 16, therefore x equals 2, or our answer is just 2. Our next one, we have log of 50 minus 2, so that's going to become division. So 50 over 2 is 25. And so we have to say 5 to what power equals 25? Well, once again, our answer is 2. Seems like that's a consistent answer there. All right, our next one. Log of 6 squared divided by 9 base 4. Well, 6 squared is 36. Divided by 9 is 4. So log of 4 base 4, well, 4 raised to what power equals 4? Well, hopefully you realize that is 1. Remember, the log of any number to the same base equals the number itself. Let's look at our last one. I threw some 10s in here. This is a common logarithm. Remember, this is base 10, even though it's not written. So this is log of 1 over 1,000. If it helps you, you can think, okay, that's log of base 10 of 1 over 1,000. A lot of ways to think of this. 10 to what power equals 1 over 1,000? Well, hopefully very quickly, I hope you realize that our answer is going to be -3 as an exponent. So our goal today is just to learn how to manipulate properties of logarithms and work back and forth, and then also transforming them back into exponential form to solve. And we're going to give you lots of times to practice on this tonight. 11 through 29 odd, 33 through 41 all. Hopefully that's going to be pretty straightforward. I did bring these into our next page and copy these down on you for you, so we'll hopefully be able to work here. Okay? All right.